right, welcome back to pre-calculus. We're going to go ahead and look at problem number 5 here. This is a word problem with exponential decay. I've got my calculator, but it's a fancier calculator than what you're allowed to use, but I'm not going to use anything on it that you're not allowed to have. Okay, so this painful bone metastases are common in advanced prostate cancer. Physicians often order treatment with strontium-89, 89SR, radionucleotide with strong affinity for bone tissue. Right? Let's see. A patient is given a sample containing 4 millicuries of 89SR. If 20% of the 89SRs, that's strontium-89, remains in the body after 90 days, what is the half-life of strontium-89? So that sounds like a great question. So let's go ahead and take a look at what's going on here. So things that we have to deal with. Okay. The 89 has absolutely no bearing on the problem. We don't care. Okay, it's just part of the background. But we are told that they're given 4 millicuries. So let's say our starting dose, we'll say that's going to be Q sub 0 is equal to 4, and I'm going to say millicuries. Okay. We are told that 20% is there 90 days afterwards, right? 20% is there 90 days afterwards. 20% remains after 90 days. Okay? And that's pretty much all they told us, but that's the information they gave us in the problem, and we have to figure the rest of this out. One of the things they didn't tell us, and you have to memorize this formula, is that radioactive decay uses Q of T is equal to Q sub 0 e to the KT. Sometimes people put a negative in here because they want their Ks to be positive. I don't really care. So um, we're going to go ahead and figure out what's going to happen with this. So what was the initial amount? This was 4. That's Q sub 0 is equal to 4 equals. How much is left after 90 days? There's 20% of that initial amount. So we're going to say 0.2, that's a fancy way to say 20%, times 4 is equal to 4e to the k. And then how many days was it? It was 90 days. So we're going to go ahead and figure out what k equals based off of this information. Okay, my first move is eventually I want to take a natural logarithm because I've got a variable in the exponent position. So let's go ahead and divide both sides by 4. Okay, so we end up with 0.2 is equal to e to the 90k. Again, the goal is solve for k. So we have a variable in the exponent position. That's our k. The way we get it down is we're going to take the natural log of both sides. So natural log of 0.2 is equal to the natural log of e to the 90k. The whole point of taking the natural log is that that comes down in front. So we have natural log of 0.2 is equal to 90k times the natural log of e, but the natural log of e is just 1, right? And then we'll say that k is equal to 1 over 90 times the natural log of 0.2. I'm going to do 2 more things here just to see how this is going to go. I know that 0.2 is equal to 1/5. And a fancy way to write 1/5 is 5 to the negative 1 power. So we're going to say k equals 1 over 90 times ln of 5 to the negative 1. I'm going to do this exactly the same thing. This is going to come down in front. So we're going to say k is equal to negative 1 over 90, because this negative 1 comes down in front, times the natural log of 5. And that's what I'm going to keep for my k value. Okay, now you are certainly allowed to go ahead and evaluate this. That would be just fine. I'm going to call it k sub s because I know what it is now. If you do evaluate this and get a number for this value, 4 significant figures. Okay, that's the rule, right? And now we have to figure out the half-life. Well, the half-life is when half of it is left. So we're going to say we have Q equals Q sub 0 e to the k. I know what this is now. I'll say k sub s t, and we're solving for t. Well, how much do I have left? It's the half-life. I want to know what half of it is left. So half of Q sub 0 is equal to Q sub 0 e to the k sub s times t. So I'm going to go ahead and divide both sides by k sub 0 or q sub 0 right off the bat, so I can go ahead and get rid of that initial amount. And we're going to have 1/2 equals e to the k sub s t. And then, just like we did with the last one, what I'm going to do is I'm going to say, well, 1/2 is a fancy way to write 2 to the negative 1. So I'm going to take a natural log of both sides. So I want natural log of 1/2, right, is equal to the natural log of e to the k sub s times t. So the goal is solving for t. This whole business comes down in front. So we have negative natural log 2. Same way I did this before. 2 is 2 to the negative 1. I took the natural log, so this negative 1 will come down in front. So negative 2, negative natural log of 2 is equal to k sub s times t. What was k sub s? Well, k sub s was negative 1 over 90 times the natural log of 5. So we're going to say this is negative natural log of 2 equals, what was k sub s? It was negative 1 over 90. Negative 1 over 90 times the natural log of 5. And all of this is times t, solving for t. Oh, go ahead and multiply both sides by 90. Okay, so we have 90, negative 90 even. So we have 90 natural log of 2 is equal to the natural log of 5 times t. Go ahead and divide by the natural log of 5, divide by the natural log of 5, and we are going to get that t equals 90 times the natural log of 2 divided by the natural log of 5, and that is going to be our answer for the half-life. Let's go ahead and figure out what this is. So let's see what we have here. There we go. I need a calculator. Okay, so we're going to say 90 times the natural log. Where's my ln? It's an ln, it's not an in. My students tell me it's in. Okay, there it is. Ln of 2 divided by ln of 5. Yep. All right, and we're going to say that's going to be t is equal to 38.76 days. So t equals 38.76. I think it tells us to round to the nearest day. So this is going to be 39 days. Okay. So that is how we've solved for a half-life. It didn't say. Excuse me. But I would tell you how many decimal places you need for this thing. Say one decimal place is plenty. Okay, so that was how we got through and solved that problem. You do have to memorize your exponential decay, your exponential growth. There's formulas you have to have the memory to be able to do these problems. Okay, but that's kind of what we're looking at as far as being able to solve this problem. So on that note, thank you very much for watching the video, and we will see you on the next one.